Hi everyone, welcome back to Array series. Hope you're doing good. This is Mahesh. In this video, we will look into Leetcode problem number 560, which is subarray sum equals to k. So let us look into the statement of this problem. So given an array of integer nums and an integer k, return the total number of subarrays whose sum equals to k. A subarray is contiguous non-empty sequence of elements within an array, and they have given few examples here basically, and then they have given constraints that the length of the array lies between 1 and 2 into 10 raised to 4. Okay, and the value in the array ranges between minus 1000 to plus 1000, and the value of k ranges between minus 10 raised to 7 to 10 raised to 7. Okay, with that, let's switch to editor. And so they will give some array and you need to find the subarray. So I have already explained in my previous video, which is maximum subarray sum. So that what exactly is a subarray? Subarray is basically any part of the array which contains at least one number and more than one number, or the entire array itself, and the numbers should be contiguous. Let us take a small example, maybe something like 1, 2, minus 1, 1, and then 3. Okay, so if this is our array, then in this particular array, 1 can be our subarray, then 1 comma 2 can be another subarray, then 1 comma 2 comma minus 1 can be another subarray, then 1 comma 2 comma minus 1 comma 1 can be another subarray, and 2 can be subarray, then 2 comma minus 1 can be another subarray, and so on. But you cannot say 1 comma minus 1 is subarray because it is missing this particular 2 in between. That's why it is not a subarray. So with that, now they will give some k value, which is 5 in this particular example. So we need to find the subarrays which adds up to give this particular k value. Say for example here 2, 3 adds up to give us 5. Then if you see 1, 2, 3 minus 1, it adds up to give us 5. So we need to find such subarrays and we need to return the total count of such subarrays. That is what this problem expects. So we have also seen the constraints for this particular problem. So with that, maybe what you can do, you can pause for a second and you can think for any possible solution, and then you can come back to this video. Okay, with that, now what is the idea behind this particular problem? So this problem basically implements prefix sum and also uses effectively hash map. So the interviewer will be looking at how effectively we use prefix sum and hash map, and we solve this particular problem in O of n time complexity. O of n time complexity. So that is what interviewer will be looking at us after giving this problem. Okay. With that, now let us try to understand the brute force solution. So I will assume you have already watched my previous video, which is maximum subarray sum. So with that, I will quickly go through the brute force solution for this particular problem. So this brute force solution is pretty much same what we have discussed in the previous problem. So before considering this example, I will consider this small example to come up with how to generate the subarray. So basically what I do, I will start from here, then I will take a pointer, then this one I will call it as start or left, this one I will call it as end or right. Okay, between whatever comes between start and end, that is basically subarray, right? So if you see, now 1 is our subarray. Okay, now if our this particular pointer, if it moves to next number, then we get 1, 2, then this is another subarray. Now I will move this to next number, so I will get 1, 2 minus 1, this is my another subarray. Now I will move this to next number. So 1, 2, minus 1, 1 becomes our another subarray. Next I will move this to next number. So entire array can also be considered as subarray here. Okay. Now after this I will move my start pointer to next number. Again I will repeat the same thing. So I will again point this second pointer here. Then I will take between start and end pointer, which is 2. Again I will increase my end pointer. Then I will take 2 minus 1 and so on. Now after doing this, what I will do, I will simply add up these numbers. So here let us assume our k equal to 3 in this second example. So we are considering this particular example now. So let us leave this example. I will go through the dry run later for this particular example in the optimal solution. But for now, for this brute force, let us consider this one. So with this, now what I will do, I will come up with the total sum. So this gives us 3, correct, right? Next, for us again this gives us 3, correct, right? And next only 3 will give us 3, so that will be another subarray. And if you see this entire part, that is minus 1 1 3 will give us 3. So basically we get 4 subarrays, which gives us k equal to 3, correct, right? So we will have to return 4 in this particular example. Okay, so this is the extreme brute force solution. Let us try to look into the pseudocode for this. Now what I will do, I will take a counter. So I will take a counter and I will say it is 0. Then I will use a for loop for start equal to 0, start less than n is basically length of nums array, then start plus plus. Okay, after this I will take another for loop for end equal to 0, end. So we should not consider 0 here, because we always start from this particular value, right? So end should start from the start value, then end less than n, then end plus plus. Okay, so this start pointer, end pointer will give us the subarray. Now what I need to do, I need to iterate over that particular subarray from start to end. Then I need to sum up the values. So I will take sum equal to 0. Then for I equal to start index, then I less than or equal to our end index, I plus plus. What I will do, I will say sum equal to sum plus nums of I. Okay, so this will give us the sum. So after this particular array, what I will do, I will check if my sum equal to k, then I will increase my counter. So I will increase my counter. So basically I will generate all these subarrays, then I will iterate and I will find the sum. If sum is equal to our value k, then I will increase my counter. I will increase my counter. So this way we will be able to get our total count. So at the end I will simply return count here. Okay, so now if you see what I am doing here, I am iterating from 0 to n. Then here almost it is inverse. I mean in the max case it is n minus 1 or almost n. So after that again there is one more for loop. So there are 3 nested for loops. So this will also run almost O of n time, correct, right? So our time complexity for this brute force solution will be of order n cube, and space complexity will be of order 1, since we are not using anything extra. So this is of concern for us now again. So interviewer will not be happy with this of n cube solution, so he wants us to improve this. So now, as I explained in the maximum subarray sum, again this particular for loop is of no use for us, because what we are doing here, initially it will be 1, then it is 1 plus the next number, then whatever this sum is common here, then the next number. So we can simply eliminate this particular for loop and we can have this sum shifted here and we can improvise this one. Let us look into that, how we can do. I will simply copy paste this part. So now I will remove this part. So now what I will do, I will say sum equal to 0 after the first loop. Next what I will do, sum equal to sum plus nums of the end pointer. Okay, so every time we keep on adding, and immediately after adding I will check if my sum equal to k, then I will increment my counter. Okay, so this way we can boil down our time complexity from O of n cube to O of n square. Okay, our space complexity is again O of 1 because we are not using anything extra. So with this, if we solve this particular problem, if you see, it is of the input length is between 1 and somewhere 10 raised to 4. So it is again not a very great solution. So we want to boil down this from O of n square to O of n. Okay, so before that, let us first execute and see. Let's take a variable count and initialize it with 0. Then let's also take n, which will give us the length of nums array. Okay, after that, let's use for loop for int start equal to 0, start less than n, then start plus plus. This is basically I'm trying to generate the subarrays. Then I will take int sum equal to 0. Then I will use next for loop with variable end, which starts from the start index basically. Okay, so end less than n, end plus plus. Then what I will do, I will say sum plus equal to or sum equal to sum plus nums of n. Okay, immediately after that, what I will do, I will check if my sum is equivalent to k, then I will increment the count. Okay, finally, after this, I will return my count. With this, let's run and see. It got accepted. I will submit this solution. It got submitted successfully. So let us take this example to get to know about the most optimal solution. So basically, most optimal solution, what it uses the concept of prefix sum and HashMap. So basically, HashMap is not a concept, but we use HashMap and prefix sum concept. So one thing what I'm trying to say here is, say for example, maybe at any ith index or ith position, assume we have sum equal to sum1. Okay. Next, maybe j, consider jth position, our sum will be sum2. Okay. Now here I will be the index which appears first and j will be the index which appears after that. So if that is the case, sum2 will be more and sum1 will be lesser. So if you say sum2 minus sum1, then if it is equivalent to k, k is basically whatever the value that they give, then it does mean there exists a subarray with sum equal to k that starts from I plus 1 to j. Correct, right? So if you have not understood, that is okay. Let's try to consider another example. So you are trying to climb this climber. I don't know, I mean, how many of you know? So assume we have some around 3, 6, 7, 8 steps. So basically 8 steps. Now you have already climbed 6 steps here. Okay. Now this is at some point you have climbed 6 stairs. Now you have k value which is equal to 2. So it means you need to check how many stairs that sum up to give 2. Basically each stair consider it's of unit length. Now if that is the case, so after second this one you might have got one subarray, then after fourth you might have got another one, after sixth you might have got another one. Now assume you already have 6 reference. Now you climbed 7th and 8th. Now if you stand at 8th stair and if you look back to your last stair which is at 6th stair, then it means the difference between 8 and 6 will be 8 minus 6 will be 2, correct, right? So if that is the case, now again you will get a subarray with some k equal to 2 at this point. So somewhat, I mean, you can assume this way. So basically j is your current stair where you are standing at, which is at 8th stair, and ith will be at 6th stair. So now if you subtract 8 minus 6, then you will get 2, right? And if it is equal to your k, then you will have a subarray there. So we will use similar concept here to get the count of total subarrays. Okay, so now considering that point, now let us try to simulate this example and see. So what I will do, I will simply remove these things. Okay, so what I will do, I will take a variable sum. Okay, then I will need to check this difference, right? So if this difference is 2, then if it is equal to our k, then we say there we have a subarray. But where do we need this hash map? This hash map is required to see how many counts are there. So basically there might be a sum. This is straightforward case, but in a different case there might be a case where we get the same term sum multiple times. So we need to keep that track. So if that sum appears multiple times, then we will have so many number of subarrays. So that count will help us in getting the total count. So we will see that in the example. Now I will take my sum equal to 0. I will take this as an initial sum. Now I will take a difference. So difference is basically our sum minus k. Okay, next after this I will take a count which is 0. Then I will simply remove this. Here I will consider a hash map. So assume this is our hash map. Okay, with this initial setup, now what I will do, now I will check my sum is 0, right? So 0 means this is a hypothetical case where, I mean, we don't have anything, we have not really considered anything, but sum is 0, so it means it is already appearing one time. So what I will do, I will simply push that 0 to map with its count. How many times it appears? It appears once. So this is our initial setup. After that I will start with each number. So now I will add 1 to it. Okay, now the sum I got is 1. Okay, so if that is the case, the difference will be 1 minus 3, which is minus 1. So there is no chance, right? I mean, we won't get any subarray because the total sum is only 1, which is very less than k. So this, for sure, this won't be available in our hash map. So what we will do, we will push this 1 because this is the sum what we are seeing now. So we might require this whenever we go above the stairs. Okay, so for that 1 appears once. Okay, now I will move to my next number. So I will add 2 to it, then its sum will be 3. So now it is very important. Now once this is 3, so basically if you see on a naked eye, 1 and 2 they will combine to give us 3, right, which is equal to k. So if that is the case, now if you see 3 minus 3, our sum is 3 and our k is 3, and the difference will be 0. If this is 0, and if you see there exists a 0 in our hash map, it means there is one subarray which gives us k equal to 3, correct, right? So now we need to consider this for our final count. So if that is the case, I will take this and I will add it to my count. Okay, so now what I will do, I will push this 3 to my hash map. So 3 is appearing once till now. Okay, with that, now what I will do, I will move to next number. Next number is -1. So the total sum is 2. So if the sum is less than 2, then we won't get anything. So simply we will check 3 minus 2, 2 minus 3 equal to -1. So obviously -1 won't be there in the hash map. Now what I will do, since we have seen this sum 2 for the first time, I will push it to hash map with count 1. Okay. Now after this, I will see the next number. Now at this number, again, I will add it and I will get 3. So now this is a special case. We have already seen 3 once. Now we are seeing 3 again. It means in the upcoming the sequence, if we get something in the hash map, then for sure there will be two subarrays which will give the sum k equal to 3. So we will see that. Now since our sum is 3, now what I will do, sum minus k will be 0. Now how many times our 0 appears here? Again one time. So I will add that count here. Okay. Now 3 appears for the second time. So I will update my 3 to second. I mean its count to 2. Okay, with this now I will move to the another number which is 3. This is again very important. Now if you see, I get sum 6, correct, right? Now if you see, 6 minus 3 will give me 3 now. So how many times we have seen 3? We have seen it twice, right? So it means there are two subarrays which will give me k equal to 3, that is sum equal to 3 at this particular point. And if we see backwards, I mean basically downwards, when we are at the top stair in the that particular staircase. Okay, so that's how, I mean, we need to analyze this. So now if you see, our 3 appears twice, so I will have to add the count to +2. So now with that, I will push my 6 to my hash map. Okay, now we are done. We move out of the array. So if that is the case, now we processed all the possible values. If that is the case, now what is my count? My count is 4. Okay, if it is 4, let's see which all arrays will give us some 3. So 1, 2 will give us 3, correct, right? Next 1, 2 minus 1 will give us 3, correct, right? Next one, -1, 1, 3 will give us 3, correct, right? 3 alone will give us 3, correct, right? Now if you observe one thing, when we were processing this particular 6, it means 6 minus 3 equal to 3, 3 appeared twice. So now if you see that we were processing this number, correct, right? So this number itself will contribute to k equal to 3 alone. Now if you look backward, these two numbers including this 3, if you sum up, again this will also contribute to my total count. So till this point, these two numbers won't contribute because their sum won't be equivalent to this k. So whenever I end up in this particular number, that time only they will contribute to our subarray with this particular sum. So alone 3 will be 1, then along with these two numbers again 1. So that 2 count is given by this particular value. Okay, hope this is understandable now. maybe with this, what you can do, you can take one more example, so which I have already mentioned here. So this will give us the clear details. You just try to dry run this and you will get to know the concept clearly. Okay, with that, let me try to write the pseudocode for this particular dry run. So now what we need a counter. So count equal to 0. Okay, I need sum equal to 0. Then I need a hash map. So basically hash map, or simply map in JavaScript, hash map in Java. So in hash map, it is something like int comma int or integer comma integer, whatever it is. Then map equal to, we say new something. Okay, this is how we create our map. Now, as an initial step, since we are seeing this 0, once what I will do, I will say map dot set or add, then this sum 0, it appears once. It appears once. This is what I will do all the initial setup. Once after this, now what I will do, I will process my array. So for I equal to 0, I less than n, where n is my nums length, nums array length, then I plus plus. Now what I will do, I will simply add my value to sum equal to sum plus nums of I. Okay, so this will give us sum. And now what I will do, I will check the difference. So difference will be basically my sum minus k. Okay, so this is basically our difference. Difference is basically this one, difference sum minus k. Okay, now with that, what we will do, we will check if our map has or contains, whichever is relevant, then I will pass this difference. If there is one in our map, then it means we got our subarray, correct, right? So I will simply say my count will be equal to map dot, here get or get, in get will be in JavaScript, get or default in Java. So I will simply say my difference. So basically difference, then I will add 1 to it. Okay, so this way, if there is value, it will take the value, otherwise it will be 0, then it will add 1 to it. We will see exactly in the code. So after that, it got added to our count. So basically it will be count plus equal to count plus equal to. So for the previous count, we are adding the new count. Then it is only when we find this difference available in our hash map. If that is not the case, every time we need to simply push our sum to hash map, because that's a prefix sum, correct, right? So I will say map dot set or add, whatever it is. Then I will say sum comma, then map dot get or default, this time get sum. Okay, then I will add 1 to it. So basically if there is value, it will give 0, otherwise it will if there is value, it will give the value, otherwise it gives 0, then I will add 1 to it. This way I'm going to increment it. So basically here the whatever I explained is a little bit wrong, because it will simply give whatever the value is there, then it will I should not add 1 to it. So basically count plus equal to map dot get of difference. Okay, so now after this, after everything is done, I will simply return my count. So this will give me the overall count. Okay, with that, if you see, we are doing everything in single iteration. That's why our time complexity will be of order n. So linear time complexity basically. And if you see space complexity, we are using this map, correct, right? So in worst case, if all the, it will store, multiple values. So in worst case, it is of order n. So this is basically our space complexity. Okay, with that, let us try to execute this. And what I will do, I will remove this for loop. I need these two things. So basically count 0 and n. Then after this, I need hash map. So I will say hash map of integer, comma, integer map equal to new hash map. Okay, then I need to initialize my map with the initial sum. So before that, I will also take int sum equal to 0. So map dot put, I will pass 0, which is initial sum, and it occurs once. Okay, so this is my initial setup. Now I will use for loop, let I equal to 0. You can also use for of I less than n, I plus plus. Now what I will do, I will say sum equal to sum plus nums of I. So this will get us the total sum. Now what I will do, I will find the difference equal to sum minus k. This will give me the difference. Now I will check if this difference is present in the map. So if map dot contains key, then what I will do, I will pass my diff. If it is there, then I need to add it to the count. So count will be count plus map dot get or default. So it is not really required. We can simply use get, but let's take that and let's pass our difference and default value as 0. Okay, with this, it will add the value to the count variable. Now after this, simply what we need to do, we need to map dot put. So basically we need to add the prefix sum to the map. So sum, then I will say get or default of sum, not difference. So I will change this to sum, then I will add 1 to it. This way I will update my map, and finally I will return my count. So hope this is fine. Let's run this and see. So there is some issue. Okay, I am missing the semicolon at the end. I'm bad. Sorry, this is my JavaScript habit. So it should be int. I run this. So it got accepted. Now I will submit. So our solution got submitted successfully. So this is how, we use this technique to optimally solve this particular problem. Hope I was able to explain this well, and I feel that you understood the basic idea between this particular problem. If that is the case, please consider subscribing to my channel, and also like the video, share this video with your friends. And if you have understood it well, please add that as a comment. And also, if you have any other queries, or if you want me to solve any other problems, you can add that as a comment in the video. Thanks for watching.